Hello everyone, Steve Goodwin here with my anchor test video number 150. Today's going to be part 2 for bow roller behavior. Part 1 concerned the 45-pound range anchors, while today we're going to look at the 20-pounders. So there's going to be 3 parameters we will look at. One is self-launching power, the other is the stability or security of the anchor when it's in its stowed or chalked position, and then lastly we'll just do a simple measurement of the shank. That'll help people determine how close they can mount windlasses or other chain equipment. Okay, we'll start off by testing the self-launching power of all the anchors, and what this concerns is a boat may sometimes have a windlass mounted far aft. This is done to relocate chain toward the middle of the boat, helps out with performance, especially with today's ultralight boats. Now, unless the anchor is mounted at an angle, either in a trough that's angled or with 2 rollers, again, if it's horizontal, it may have difficulty dragging a significant amount of chain over the edge. And unless a crewman goes forward to give an anchor a kick, they won't be able to just deploy this anchor remotely with, let's say, a remote control for a windlass. So I'll test the power that they have to do this simply by seeing how much chain each of the anchors can drag. Now, before we get to that, you may be wondering why test 20-pound anchors with this, since most boats with this small of an anchor probably won't even have a windlass. And I agree. The difference, or the reason I'm doing this, is because the 45-pound range testing and charts that I have put out, that's the big anchors, is becoming obsolete in my view. I have done so much more testing in far more seabeds with the 20-pounders now. Again, I think the 20-pound data is superseding or is far more valuable than the 45-pound stuff. And I think more and more people are going to look at that range, and I would like to include these self-launching numbers. Certainly there's people with larger boats that will use the 20-pound data and just simply extrapolate, and again, I wanted to include all available data for all these anchors. And before we begin, I'll mention that this is a smooth-faced bow roller without a groove. The diameter is 2 7/8 inches. Larger diameters would tend to increase launching power. Smaller diameters would decrease it. This is a dead level trough, and any angle from the stowed position would increase or decrease launching power. And lastly, I'll say that all these launch tests begin with the anchor fully pulled aft or in its stowed position. Let's begin. We'll start off with the 23-pound Bruce copy. This is a Lumar Claw, and it has 0 self-launching ability. Now, just for kicks, let's simulate a 2-roller setup where the inboard roller is higher, and you can see the shank has a bit of an angle. Now the anchor can self-launch about 10 feet. Here we are at the 10-foot mark. And away she goes. This is the 21-pound Bruce anchor, and it has 0 self-launching ability. This is the 26-pound CQR, and for all intents and purposes, it has 0 self-launching power. What happens is there is a jog or a lip here on the underside. You can't see it, but it's just like the same on the top. That sort of hangs up on the roller, and as we can see, it will, it's maybe 6 inches, or just those shackles are enough to hold it. Then it goes. This is the 21-pound Viking anchor. Here's the 6-foot mark. No self-launch. And 5 feet will just launch. I'll do that again here. 5-foot mark and it self-launches. Now, you may recall from the previous large anchor video that the 51-pound version of this anchor had 0 self-launching power. And I believe the difference is when they've scaled this anchor up, the materials are scaled fairly accurately with the exception of the roll bar. In fact, both anchors use the exact same roll bar section. So therefore, it's very easy to see that a higher percentage of this anchor's weight will be comprised of the roll bar, shifting the center of gravity aft such that it's able to self-launch with more authority. This is the 24-pound Delta. And here at the 7-foot mark, we'll see that it will just self-launch. This is a 20-pound Danforth 18H. And here at the 7-foot mark, £22 roll bar Rocna, and it self-launches here at the 9-foot mark. £17 Mantus M1, and this is the 10-foot mark. This is the 15-pound Fortress FX23. Here's the 10-foot mark. This is the 21-pound Excel number 2. And here we are at the 16-foot mark. 22-pound Quickset. And we come to the 17-foot mark here. This is a 21-pound Spade anchor, and just before the 17-foot, it started to move. So 17 feet for the 21-pound Spade. 17-pound Excel number 1, and here is the 14-foot mark. This is the 18-pound Wedge anchor. Notice that it has the optional wedge palm installed. This will move the center of gravity of the anchor aft and will slightly increase the self-launching power. Here's the 15-foot mark, and there she goes. This is the 17-pound Mantus M2. It has quite powerful self-launching ability, and here's the 15-foot mark right here, and that's what it's able to pull. And last but not least, we have the 21-pound Vulcan. That's 21 feet of chain. Drags it no problem. So clearly there's a wide range of self-launching power among all the anchors, and I would argue that the very best anchors are probably more than you would ever need. Consider that this test was conducted with 5/16 chain, which is heavier than, say, the 1/4-inch chain, which would be more typical for this size anchor. And if you use the smaller chain, well, the better anchors could likely pull more chain than the length of the entire boat that they are being used on. All right, let's get on to the next test. That is the stowed or chalked anchor stability. Now, bow rollers and bow setups are going to vary just almost infinitely by all the different boats out there. Some boats will have a sort of a bowsprit platform with a slot. The bowsprit itself might help chalk an anchor, or maybe anchors sort of run into or chalk along the side of the stem of the boat. It's impossible for me to test all of that, so I'm just going to focus on a simple, just a single bow roller with cheeks that stick down a little bit, and we're going to test which anchors can remain stable with only just pulling on the road. In the real world, many people, and they're correct, they should and do tie off the anchor with a line, or they have perhaps extra chocks or devices for the anchor to run into in the chalked position to stabilize things. There's even commercial products out there that mount onto a standard bow roller. Again, they'll have a bumper, if you will, say down low to help stabilize the anchors. But for this test, it's just going to be for this kind of a bow roller, and let's just see which anchors do the best. We'll start off with the worst performers and work our way up. 17-pound Mantus M2. So, center of gravity is far, far below the pivot point. So lots of energy, lots of momentum. Obviously, waves are going to be able to lift this up. I can feel when it clunks over, I can feel it lurching. That would be very loud on a boat. Okay, this is pretty much no man's land. No place for the anchor to really notch into. It tends to end up right about here, but again, there's no nub, nothing to prevent this from moving around. Same thing, smaller, and nothing to keep it locked angularly as well. 21-pound genuine Bruce. So not only is the anchor moving angularly, it's also sliding back and forth across the flat face of that bow roller. Certainly a wave coming up from underneath could make that motion happen. £23-pound claw. That is a nice fit there, same diameter, but doesn't really do anything for stability. Same with the small size. 21-pound Vulcan. Very low center of gravity. Maybe not quite as bad as that M2 in terms of its energy and slamming, but pretty close. Nothing to lock angular motion. It's only touching at a very tiny point. 21-pound Viking. So it can move angularly, but when it slides over, it sort of runs into the cheek of the bow roller and kind of straightens out. It does have a nub built into the shank that theoretically would prevent upward motion with enough road tension, but the angle is such that it doesn't take much flex in the system and it can just come right up. Center of gravity is well below the roller. That's a bit of lock there. It touches here, and if it's sucked in tight, that would actually prevent some angular motion. Okay, not much lock here because it's touching there first. At that point, it starts to lock. And that point, but in the middle here, it's only touching in that middle spot. 21-pound Excel number 2. Okay, lots of motion this way. It's also sliding back and forth across the roller face. There is a nub, if you will, formed into the shank that's designed to lock into the roller. However, the diameter that was designed to accommodate is probably smaller than this roller. This is pretty big, and what it means is it doesn't take too much upward pressure to sort of jump over that little nub. It would then lock into this position real nicely, but there's no way to get to that point without physically lifting up the anchor, meaning you couldn't get it up to here simply by pulling on the road. This is the Excel number 2. It's a little bit better situation than the smaller anchor because this bite is larger, so it can accommodate this larger roller better, but still, it does have the ability to jump that fairly easily. Again, the smaller diameter would be better. 18-pound wedge. The anchor does have a nub in which the roller could chock into, and it does, but again, this is a large diameter roller, so it's not a perfectly secure fit. A wave could easily bring this up, even with large tension on the road. For this large roller, the nub, it's not really big enough. This should have been opened up larger, in my view. That's a great fit for the smaller roller. It would be hard for it to jump over that, and better angular locking as well. 26-pound genuine CQR. Okay, it's mostly just side-to-side motion. Very little tipping. Looks like it's able to tip, but when it's rocking, it just doesn't do it very much. My guess is that the center of gravity is very close to the pivot point, or the roller. We've got a lot of mass here, lots down there as well, but overall not too unstable here on the bow roller. And that's a great lock for this size roller. Smaller roller might move up and down a little bit. 22-pound Rocna. So this shank has a definite notch that is real positive. It does not let the anchor come up, and looks like the shank, or the fluke, is close enough to the underside of the roller frame that it somewhat limits the side-to-side motion. But yeah, up and down is fully locked. Okay, that is a perfect fit. That radius is exactly the same, and that's going to tend to lock it in place angularly, and up and down wise it's a nice lock as well. The smaller diameter doesn't fit as well. That's going to tend to rock more. 22-pound Quickset. So this shank is shaped such that the anchor can chock right into the fluke and the underside of the shank into a V. So it's extremely secure up and down. That's the only place it can be. And the contact points on the roller are quite far, and with enough tension you could probably completely immobilize even this rocking. But certainly the center of gravity of this anchor is not terribly low, and not a whole lot of energy gets developed as it starts swinging. It's pretty reasonable motion. The Quickset's angle here is very, very much going to very strongly force the roller all the way down into that notch. Be very, very secure up and down wise. Same thing with the smaller, it just travels farther into the notch. 24-pound Delta. So totally secure up and down, a little bit of movement this way. The flukes are not touching the roller cheeks, and the roller is wedged in between the fluke spine and the shank. Very secure. Just a slight bit of motion potential. The center of gravity is not terribly too far down, so any motion that does develop isn't going to generate a ton of inertia. Okay, the Delta's geometry allows any size roller to just end up right down in here between the spine of the fluke and the leading edge of the shank. That was a nice fit. Let's take 2 for the 17-pound M1. So it's excellent. The fluke is jammed into the roller cheeks, and even if the roller cheeks were smaller or higher, there's still distance that the anchor can travel up before it seats into its chock, which is a shape that would definitely hold the anchor well. Center of gravity is nice and high. It's probably right in line with the roller. So even if the anchor could pivot, it wouldn't do so with a lot of force. Again, the center of gravity is in line with its roller contact point. So in the case of my wooden mock-up, the cheeks of the roller buried right into the shank here. If it was a more compact roller, which would be very likely on a smaller boat, that this would have been doing some rocking for sure. But if you were going to modify it, it'd be very simple to add some extended cheeks or blocker stops that would only have to protrude down a short distance, and then they would lock the anchor in place. Even this large roller doesn't chock between here and here. It's actually touching on the face there, and therefore you're going to get that. Even more so. In my view, this should have been a curved or perhaps a V, so that any sized roller could lock in place. That's probably ideal, rather than these curves that we see on some of the other anchors, is to just let it be a V. Now structurally that's not as good. You're either going to have to add more material or compromise the strength, but I think that could be accommodated with most shank designs. 21-pound spade. Brilliant. The shank is shaped such that the upper side of the fluke rams up and lodges into the roller cheeks. And even if there was, say, smaller roller cheeks, the anchor would continue to go upward for some distance before it ran out of, say, upward travel. So, yeah, that's nice and secure. Center of gravity is not too much below, but it doesn't move, so it doesn't generate any force. So, very good. Now on the spade, it just tended to geometrically just rode right on down and then buried the edges of the roller into the top of the fluke. Very solid. I'm guessing a smaller roller would do similar, but maybe not quite as strong. The point of contact is going to be down lower and is more vertical. 20-pound Danforth 18H. It's absolutely solid in every direction, and it's just the nature of the beast. The two fluke halves, they jam up and lodge underneath the roller cheeks, 100% stable. You could potentially end up with that, given this wide distance here, but a little coaxing to get it right in the right spot would be very secure. Obviously a wider roller is better. Actually, with this one, the roller cheeks that hung down a little bit would lock into this perfectly. 15-pound FX23 Fortress. Just like the Danforth, completely rock solid. This is a perfect example of how you could make a anchor 100% foolproof locked in. It just wedges into 3 points into a triangle, no motion. And any size roller, it's just simply going to go farther. Well, once again, that was a very wide range of performance or stability between all the anchors. Now, I'm going to tell you a little story about what inspired me to do this test. Several years ago, one of my viewers, he's a local boater, he hired me to bring a handful of anchors down to the dock in front of his boat. And what he wanted to do was buy a new anchor, and he simply wanted to find out which anchors were going to fit the best. And the first anchor we put up there was a 55-pound Vulcan, and this was on a Grand Banks trawler. Took him 2 seconds. As soon as he put it up there and moved it around, he said, nope, that's not it. I'm not going to have that anchor. It didn't matter how well that anchor performed, how strong it was, or how available. He just was not going to have it. And I think it was wise. This had a platform-style pulpit, and I think the roller was right at the very end. There was a hoop that would contain the anchor from jumping overboard completely, but it was pretty clear to see that it would have taken a whole lot of shenanigans with rope or perhaps other equipment to get that anchor to settle down, and he just wasn't going to do it. We just picked an anchor that chocked nicely and it was fairly stable. Ended up being an Excel that he chose. Okay, the last parameter we'll look at is the shank length data, and there's really not much to see, so I'll just show you the list. But before I do, I'll explain how the measurement was made. I went to the center line of this 2 7/8 inch diameter bow roller and measured aft to the extreme aft edge of the chain attach hardware. In this case, it is a single shackle, and in the case of other anchors, such as the CQR, there's 2 shackles needed. And if that was the case, I measured to the aft face of the last piece of equipment. It's going to tell you pretty accurately where the windlass or the Wildcat can be located. So before I sign off, rather than another update on Panopé's fuel system refitting, I'll mention that she made the cover of the latest Professional Boat Builder magazine. This is the August-September 2023 issue, and it covers my lengthy refitting and rebuilding of this boat for over the last 25 years. I'll mention that the author chose a rather appropriate title for the article: Perpetual Refit Machine. Now, my thought was that he was talking about the boat, but my father, his take was that perhaps he was talking about the combination of myself and the boat being the machine. Either way, I found it appropriate. Okay, I'll leave you with the latest updated 20-pound range anchor data, and at the far right-hand columns, you'll see those 2 new columns for those anchors. That is the self-launching power and the stowed security. Enjoy.